Good day, class. It's Sir Capistrano again, and welcome back to another lecture. And for our Chem 21, and this is lecture 6, which talks about alkynes. So, by alkynes, as we know, this is another set of organic compounds that only have carbon and hydrogen atoms, which we call aliphatic hydrocarbons or aliphatic organic compounds. And by alkynes are actually unsaturated aliphatic hydrocarbons that contain carbon to carbon triple bond, which has a molecular formula, general molecular formula of CnH2n minus 2. So that minus 2 is again corresponds to the missing hydrogens due to additional pi bonds that that makes up our triple bond. So when we talk about those triple bond, as you may have remembered in our discussion on alkenes, the double bond, the other bond, uh, besides the sigma bond or what we call pi bond, corresponds to the second bond. And for alkyne, the third bond is actually another pi bond. So when we talk about alkynes, we actually have one sigma bond and we have two pi bonds. So like our discussion in alkenes, okay, this pi bonds will be another set or another sites for what we call sites for reaction or what we call functional group. So when it comes to alkynes, or for this discussion, we will be again tackling the structure and nomenclature of alkyne. Then we will be moving to the physical properties of alkynes, and we will also talk about some of the reactions involving alkynes, which will actually revolve around those pi bonds, being our carbon here as sp3 hybridized. So let's move on to the structure and nomenclature of alkynes, in which uh, s- structure and nomenclature of alkyne actually has the same system with alkenes. It talks about the nomenclature, wherein for alkynes, instead of in, we will be replacing that with "-ine" or YNE. So in that, let's have here some examples of alkynes. So for alkynes, since alkynes is characterized by a triple bond, the smallest structure or the smallest organic compound or the smallest alkyne will be actually what we call ethyne, or also known for its common name, which is acetylene. Some of you may have heard of this acetylene. This acetylene is actually used in blowtorches or in welding. So it has a structure that looks like this. So we have, by being et, we have two carbon atoms, and those two carbon atoms has a triple bond, and we have here our hydrogens. So that is the most or the simplest member of the alkyne family. So next will be the propyne. So I have here also some examples. So one example here is our 2-butene. So let's first write the name. So we have here 2-butene. By but, uh, that means four. So I have here four carbon atoms. So we have one, two, three, four. And as you may have remembered on our discussion of alkene, if we have here this number two, that means our ine or our triple bond is located at the second carbon. So we can start here at the left. So count here, and this will be 1, and this will be 2. Okay, then the triple bond starts at 2. So I have here 1, 2, 3. Then I have here this single bonds. And for these carbons, we will have here 3 hydrogen and another 3 hydrogen here. So we have here 3 butyne. So how about this one? So say we have here H2C, CH3. That should be CH2. Then I have here this one. I have here the triple bond, and another carbon, and another CH2 and CH2. As you can see here, if we count the number of carbons, we have here 6. I have here 1, 2, 3, 4, 5, 6. So, for in naming this, this organic compound, it follows the same concept with our alkene wherein we just need to count or find the parent chain. So this is a straight chain. So this will be our parent chain. Then we just need to position our triple bond on the we will be giving the lowest possible number or lowest possible position for our triple bond. If we start here at the left, it will be 3. And if we start here from the right, have here 1, 2, 3. Same, we have 3. And we have here 6 carbons, so that will be X. And instead of in, we will be using "-ine" or YNE. And giving the lowest position, so we have here 3 hexyne. Okay. And lastly, let's have this compound. I have here CH3. I have here a bond. We have here this one. We have triple bond. We have here our CH. We have here our CH3. And we have here another CH3. So for this one, same concept with alkene. We just need to find the longest chain. So the longest chain can be this 1, 2, 3, 4, 5. Or it can be 1, 2, 3, 4, 5. It can also be the other way around. So it can be 1 here, then 2, 3, 4, 5. And same concept here. On the bottom, we can start here as 1. Then we have here 2, 3, 4, and 5. But since we're following the same concept with the, the alkene, we will be giving the lowest possible position for our triple bond. So that will be this carbon 2, and being 5, that means this is actually pent. And since this we have a triple bond, this will be "-ine." Then we will just have one of the substituent. So if we get this chain as our parent chain, we have here a methyl, which is actually located at our fourth carbon. So we will have here 4 methyl. Then don't forget the position of the "-ine. Same concept with alkenes. So this will be 2. We have here 2. So this compound is actually 4-methyl 2-pentyne. Okay? I have here other examples. So what if instead of 2, we have 1 butane? What will happen? So if we have 1 butane, what will happen here is we just have this carbon, this first carbon, have this triple bond, and we have here our hydrogen, then we have our CH2, CH3. Okay? How about if we use hexyne, but instead of 3, this is 1. So we have here 1 hexyne. What happened here is same concept. We have here our first carbon, then we have here our triple bond, we have here our hydrogen, then we have here our four uh, carbon. So we have here one, two, three, four. Okay, so that will be our one hexane. And how about 4 methyl, 1 pentyne? For this one, since we have here 1 pentyne, it means that our triple bond is located at our first carbon. So same concept. We have here our first carbon, then we have here our triple bond, we have here our hydrogen, here our other carbon, then we will have here our third carbon. So we have here CH2 that is bonded to our CH that contains our methyl and another methyl group. So that will be 4 methyl 1 pentyne. So, kung mapapansin nyo class, pinaghiwalay ko sila. Ano? So we have here this 2 butane, we have 3 hexane, we have 4 methyl 2 pentyne. Then on the other side, we have 1 butane, 1 hexane, and 4 methyl 1 pentyne. So what is the difference between those groups? Papansinin nyo, we have here this group, and we have here this group. Okay? So as you can see here, class, we actually have two types of alkynes. Okay? Meron tayong mga alkynes kung saan we can find our triple bond inside the chain. Okay? And we can also see, or we can actually see here, alkynes that have their triple bonds dun sa pinakang dulong chain or sa dulo ng chain natin. So in here, actually class, we have two types of alkynes wherein this group actually is called what we call internal alkyne. And in here, in the other side, we actually have here our terminal alkyne. So basically, when we talk about internal alkyne are alkynes that have their triple bond inside the chain. Wala siya ron sa first carbon natin. And when we talk about terminal alkynes, these are alkynes that have their triple bonds. The triple bond is positioned on our first and second carbon. Okay, so that's our structure of alkynes. So we have there our structure and nomenclature of alkyne. Wherein we talk about how we can name our alkynes, and also we also determined our the classifications of our internal and uh, terminal alkyne. So how about cyclic analogs of alkynes? So basically, when we talk about cyclic analogs, ito yung mga pabilog or nagpo-form ng chain. So when we talk about alkanes, the simplest form of cycloalkane is actually the cyclopropane. When we talk about alkenes, nagkaroon tayo din ng cyclopropene. But when it comes to this triple bond or what we call alkynes, medyo magkakaroon tayo ng problema when we have those smaller cyclic compounds. So basically, the smallest cycloalkyne is what we call our cyclopropane. So, actually class, walang cycloalkyne na mas maliit kesa rito sa cyclopane. So, bakit kaya? So as you may have remembered, when we have talked about cyclopropane actually has what we call bond strain due to the cyclic formation or its cyclic conformation. So when it comes to alkyne, mas nag mas nag mas nabibigyan ng tawag dito. Mas nagkakaroon ng tinatawag nating stress. So let me just show you. So, okay class. So when we talk about cyclooctane, kung makikita nyo ron sa slide, hindi yun actually yung pinakang itsura niya. Ano? It will not form that regular structure as we may know. So, ano ba yung magiging itsura ng ating cyclooctane? So, when we talk about cyclooctane, ito actually yung mangyayari dyan. Ano? So, we have there our triple bond. Okay? So, we have here one, two, then three. We have those bonds, and we have here the carbon. So we have here one, two, three, four, five, six, seven, eight. So kung makikita nyo class, hindi actually siya nag-form nung expected nating shape ng octagon or regular octagon due to this triple bond. As you can see here, there is actually a bond strain in here wherein imbes na straight siya, nakabend siya towards the cyclic analog due to due to its formation. So as you can see here, due to this triple bond, pag tinanggal actually natin yung ibang bonds na yan, and we consider this triple bond, as you can see here, andyan na yung strained na yung bond. And additionally, as you can see here, straight yung nagiging conformation natin. By straight yung confirmation, nandito yung isang R group natin and yung isa pang R group natin. And kaya nagiging impossible yung pagkakaroon nung cyclic analog na mas lower than octane bukod sa wala tayong magiging bond rotation dito due to the existence of the triple bond. Well, actually, kahit double bond naman siya, wala tayong bond rotation. So, wala tayong magiging katulad nung sa cyclohexane dati na mga conformation. So, basically, limited yung conformation na nangyayari when it comes to octane. So, bale, ang pwede lang actually magkaroon ng conformation dito or nung tinatawag nating positioning ay itong dalawang bond na ito na restricted pa din kung titingnan nyo. So, as you can see here, I have a hard time na i-rotate yung mga bonds dito due to that existence of that strain. Okay? So, as you can see here, this one, hindi mo siya actually matutwist. Okay? Yung twist niya is just about this one. This carbon lang. This one. Pero, hindi na siya actually magkakaroon ng tulad nung cyclo uh, alkane natin or sa cyclohexene na pwede ka magkaroon ng chair conformation. So, actually, tingnan nyo. Once we remove the triple bonds, mas magiging free yung ating molecule to move around at magkaroon ng iba't ibang conformation. Hindi katulad kapag restricted siya ng triple bond natin. So, that is the reason why our simplest cycloalkyne is our cyclooctane. Okay? Going back to the slide. So in that, pakitandaan na lang po, our simplest cycloalkyne is our cyclooctane. So, let's move to our physical properties of alkynes. So for the physical properties of alkynes, let's look into this for organic compounds or for alkynes or representative of alkynes. So as you can see here, all of this are actually terminal alkynes. So hindi ko pa na-check yung data regarding sa internal alkynes. So when we have this terminal alkyne, these alkynes are actually weakly polar. So by weakly polar, these terminal alkynes actually what we have some slight dipole moment. So by slight dipole moment, we may consider that as pwede tayo magkaroon ng much positive side or slightly negative side and slightly positive side. So nagkakaroon tayo ng tinatawag natin na polarity. So, but it is actually very weakly polar. So by weakly polar, ano ba yung nagiging dahilan kung ba't tayo nagkakaroon ng weakly polar na yan? So for these examples, actually those weak polarity, the reason for that weak polarity is actually the triple bonds. So that is the reason why nagkakaroon tayo ng weak or very weakly polarity. So, due to the existence of the triple bond, so bakit nagkakaroon ng weakly polarity? Due to the presence of electrons. As you may have remembered, when we talk about bonds, bonds are actually composed of electrons. And in this, since we have triple bonds, and since each bond has two electrons, we actually have here six electrons. And those six electrons contribute to the slight polarity of the terminal alkynes. So by slight polarity, we will have here a side which is medyo a negative, and we have here this side which is since we have here a proton dense side wherein we have here hydrogens and we have here carbons. We have here our slightly positive side. So, but ulitin ko lang, it is it is very weakly polar. So, basically, alkynes also follows the physical properties of alkanes and alkenes. So, as you may expect, it follows the same orientation when we talk about the physical properties of alkynes. So by physical properties, one of our indicators when we talk about polarities or properties is the boiling points. So by boiling points or our B points, we can actually see that the same pattern applies when it comes to our alkynes. So, for example, I have here one, two, three, four, five. So we have here one pentyne. Let's compare that to one, two, three, four, five, six. One hexyne. And I have here one, two, three, four. I have here three methyl, one butane, and I have here three three dimethyl, one butane. So bakit three three? Because we have here two methyl groups. So kaya siya three three dimethyl kasi this will be one, two, three. So again, going back to boiling points. So we have here one pentyne, one hexyne, three methyl, one butane, and three three dimethyl 1-butane. As you can see here, for the first three, by three, I mean the 1 pentyne, 1 hexyne, and 3 methyl 1-butane actually have the same number of carbon atoms. So 1 pentyne has 5 carbon atoms, and butane has, again, we have here 5 carbon atoms. except for our hexyne pala. So as you can see here, when we talk about pentyne and 3-methyl 1-butene, nagkaroon lang tayo actually ng branching. So when comparing these two, you can see here that mag-a-apply pa rin yung ating van der Waals forces of attraction or yung tinatawag nating London dispersion forces, wherein this one pentyne actually have boiling point of 40 degrees Celsius, and our 3-methyl 1-butene actually have boiling point of 29 degrees Celsius, which may appear gas in room temperature. So as you can see here, due to that branching, ganun naman ulit, bababa na naman yung ating surface area kasi mas umikli yung chain natin and mas nag-clump and nagtago yung ibang surface area natin. Therefore, we have a lower temperature. So again, same pa rin yung trend. Increase, pag same number of carbon atoms, pag nag-increase ka ng branches, bababa yung surface area, decrease in surface area, therefore decrease in London dispersion forces or van der Waals forces of attraction, therefore decreasing din yung ating boiling point. Okay? That is true for the same number of what do we call this? Same number of carbon atoms. So, as you can see here naman, from one pentyne to one hexyne, nadagdagan tayo ng isa pang carbon atom. So, due to that, we can expect nagkaroon tayo ng increase sa surface area. So, kapag mas mataas yung longer chain length, again, we will have here higher surface area. That will mean higher London dispersion forces, and that will mean by our uh, by, by our concept of alkane, we will have here higher boiling point, which is actually true because one hexyne has a boiling point of 72 degrees Celsius. Okay, but as you can see here, 3,3-dimethyl 1-butene, I forgot a dash there, and one hexyne actually has the same number of carbon atoms. So you can expect na siguro mas malapit sa isa't isa yung ano nila, yung tawag dito, yung boiling point nila. But that can't be true because the boiling point of 3,3-dimethyl 1-butene is actually just 38 degrees Celsius. Okay? So as you can see here, nag-increase na naman yung number of branches natin for the same number of carbon atoms. But since marami yung branches, mababa yung ating boiling point. And actually, kapag i-check nyo, if you have, say, 3-methyl 1-pentyne, isipin nyo parang ito lang yun. Itong pentyne lang natin, dinagdagan lang natin ng isa pang branch dito na methyl. Ang mangyayari actually dyan, mas magiging mababa din yung yung boiling point niya when compared to hexyne. So that is the physical properties of alkyne. So again, we are just using the boiling points as our indicator regarding how uh, how each organic compound attached to each other, therefore dictating what we call our physical properties. And that physical properties is actually related to what we call intermolecular forces of attraction. Okay. So again, if you are confused regarding this, you may post your comments in this video. Also, you can send me a direct message regarding your question. So, Moving on to the reactions of alkynes. So basically, when we talk about reactions of alkyne, it is actually comparable to the reactions of alkenes. And by reactions of alkenes, this is actually related to our pi electrons again. So since in alkynes we have two sets of pi bonds or pi electrons, we can expect that there is a loosely held bond when it comes to these bonds or these pi bonds. And due to these pi bonds, nagkakaroon lang din actually tayo ng mga tinatawag nating addition reactions. So we have here most of these reactions are actually addition reaction, and some of it are actually electrophilic addition, just like alkene. And also, when we talk about alkyne, nagkakaroon actually ng scenario na yung kung meron kang alkyne and it may undergo a reaction wherein it may be converted to alkene. Then, after being converted to alkene, it may be converted again into alkane. So, ang kailangan mo lang dun actually when it comes to those types of reaction, you just need two molar equivalents of your reagents for the reactions to proceed from being an alkyne to alkene to alkane. So again, in most of this reaction, if you add two molar equivalent of your reagent, by reagent, let's just write that as reagent, say A. Kapag nag-add ka ng 2A, yung alkyne mo, or if you add 2 molars of your reagent or your alkyne, it will be converted to alkane. And if you only add, so if you have alkyne and you just added 1 molar equivalent of your reagent, it will be converted into an alkene. So basically, when we talk of alkyne, we will be just again talking about the reactions of alkene. Wherein, as you may see here, we have here familiar reactions that alkene in which happens with in which it happens with alkene. Sorry about that. So, hindi ko makita yung English ko ngayon. But anyway, let's move on to the first reaction mechanism of alkyne, which is hydrogenation. By hydrogenation, as you may have remembered, we will be just adding hydrogen or just H, not H2. So in that, how do this reaction proceed? So actually, we have three types of hydrogenation in which alkynes may be involved into. So if you have here our basic structure of our alkyne, in which we have here our triple bond in our R groups that are attached to those carbons, pwede actually tayong magkaroon ng tatlong types ng reaction depending dun sa kung anong type ng reagent yung ginamit natin. So, as you can see here, or as I said earlier, if we have 2 molar equivalents of hydrogen, and we have nickel, platinum, or palladium as our catalyst, this will actually proceed to our alkane. Tatanggal yung triple bond natin, and dun sa triple bond na yon, magkakaroon tayo ng alkene. So, we have here our alkene. So, we can actually directly convert our alkyne to alkane by simply introducing 2 molar equivalents of our hydrogen. So, kumbaga, Kung meron kang 1 molar ng ano mo, ng iyong alkyne, and you added 2 molars of 2 moles of our hydrogen, and you introduce nickel or platinum or palladium as your catalyst, it will be it will become an alkane. Okay? So another hydrogenation reaction actually happens in the presence of salt, or not salt, sodium or lithium. Then we will add our uh, liquid nitrogen. No nitrogen, not nitrogen, liquid ammonia. And in here, we will actually have what we call a transalkene. So by transalkene, we will have here our alkene. Then, since we have hydrogen from our nitrogen, we will have here our hydrogen. And by trans, it means that the other hydrogen will attach itself to this carbon on the other side. So we have here our trans alkene. Okay. So for the last type of reaction, we have here our hydrogen, wherein for this one, wala tayong tawag dito, wala tayong 2 molar equivalents of hydrogen, and we use what we call Lindlar catalyst. We will have here what we call a cis alkene, wherein by cis alkene, these 2 hydrogen will actually attach themselves to the same sides of our double bond. So we have here our cis alkene. So again, trans and cis are just geometrical conformation of our compounds, or our side substituents. Okay? So, for example, let's use tubutine. So, with tubutine, as you may have remembered, tubutine is just CH3. Then we have here our triple bond in our second carbon. Then we have here our carbon, another carbon, and another CH3. So this is tubutine because our triple bond, or the lowest position of our triple bond is 2. So we have here tubutine. Okay? So if this tubutine undergoes with this reaction, what will happen? We will just have butane, wherein butane is just CH3, CH2, then we have their single bond, CH2, then we have here our CH3. Okay? So what if our tubutine undergoes a reaction with sodium or lithium and our liquid ammonia? What will happen here is, let me just remove this transalkene so I have space. So we will just have what we call our cis, or not cis, trans butene or 2-butene, wherein we will have here our double bond. Since we will be having trans, our CH3 here will be here, and we have here our hydrogen. We have here our hydrogen, and we have here our CH3. So that is our trans to butene. And lastly, for if we introduce our 2-butene to our hydrogen and our Lindlar catalyst, what will happen here is we will have here an alkene, and our CH3 will actually be located on the same sides of our double bond, and we have here our hydrogen. Basically, class, we have here 3 different reactions uh, involving hydrogenation, or for the process of hydrogenation. Okay, so let's move on to our electrophilic addition. So for electrophilic addition, as you may have remembered, we have the three types of electrophilic addition wherein we will be adding halogens. We will be adding hydrogen halides and also our hydrogenation or the addition of water. So that first, let's discuss our addition of halogens. This is actually follows the same concept when we talk about our alkene. So in here, we will be just adding our halogens. So it may actually exist uh, in different reactions depending on the uh, equivalent molar equivalence of our halogen. So, for example, if we have here our triple bond here, general formula of triple bond, and if we added 1 mole of our halogen, our reaction will actually proceed in a way na magkakaroon lang tayo ng double bond and our halogens will be attached in a syn addition way or anti-addition way, wherein we will have here our alkynyl dihalide. But in instances that we have this, say, this triple bond or our alkyne, and we added 2 moles of our halogen, what will happen here is magkakaroon tayo ng ating alkyl tetrahalide wherein kung ito yung ating original carbons which are attached by triple bonds, kakaroon tayo dito ng ating halogens. By tetra, that means we will have 4 halogens. So, for example, say we have, let's have our 2 cyclohexyl 1-ethyne. So, ano ba maging itsura na? So, we have here 2 cyclohexyl. So that means it is a cyclohexane that is attached to our ethyne. So, what happen here is we will have here our ethyne. That means 2 carbon atoms na meron tayong triple bond. And we have here our cyclohexyl. So what will happen if we added 2 moles of bromine gas in the presence of carbon tetrachloride? So what will happen here, since we have 2 moles of bromine, we will have here this structure. So wherein magkakaroon tayo nitong ating yung ating 1122 tetrabromyl cyclooctane. Ayan. Ay, hindi pala. Cyclohexane pala yun. Anyway, yan. 2, 2, 1122 tetrabromyl 2 cyclohexane. So that will be our our product. So gusto nyo ba isunod ko? So that will be 1, 1, 2, 2. Tetrabromyl 30. ethane. So that will be the name of our, I think that will be the name of the product. So, i-review na lang natin yung class pagdating natin sa alkyl. So, that is our electrophilic addition involving addition of halogen. So, for our next electrophilic addition, we have here our addition of hydrogen halide. So, by addition of hydrogen halide, same concept when it comes to addition of halogens. But for this one, it will actually follows our Markovnikov's rule, as you may have remembered. So Markovnikov's rule, in Markovnikov's rule, we will be adding our hydrogen, and for this case, that is our electrophile, to the carbon with the higher number of hydrogen. Or pag nagkaroon tayo ng ating internal what do you call this? Internal alkynes, medyo magkakaroon tayo ng problem when it comes to those types of alkynes. So, bale, ang mangyayari doon, magkakaroon tayo ng multiple products for that one. But when it comes to the terminal alkyne, mas madali siyang makita. But anyway, makita na lang natin. So, by addition of hydrogen halides, we actually express that as HX, which can actually be our HCl, our HBr, or our HI, or hydrogen iodide. So, in that, this is the general formula for that. If you have here your alkyne, and you added your hydrogen halide, say you have here your HX, what will happen here is we will have here a scene addition. By scene addition, same side. So cis tayo dito. We will have here our H and our X. So just to note, we have here our H and we have here our X. Okay? So, what will happen if we added another set? So, it will just follow the reaction of our alkenes. And for this time, it will follow the Markovnikov's rule. Since you attach your hydrogen here, meaning it has a higher number of hydrogen in comparison to this one. So what will happen is we will have here our carbon, wherein we will have here our hydrogen. Then, another carbon, single bond na lang siya. And we have here our X and our X. Or by X, it means our halide. So basically, we will have here our uh, geminal dihalide. By geminal dihalide, it follows the Markovnikov's rule. And two of the halides are actually attached to the same or to similar carbon or to the same carbon. So for example, let's use propine. So daya ako gumamit ako. Huwag na pala. Let's use 2-butene. So by 2-butene, we have here 4 carbon atoms and second carbon. We have here single bond, H3, H3. Then we introduce them to HCl first. So, bali dito mangyayari class, since ano naman siya, symmetric. So, kahit sa side na siguro. So, we will have here our H3C and our carbon. We have here our double bond. We have here our CH3. Then we will have here our hydrogen and our chlorine. And if we proceed with addition of another HCl here, what will happen here is we will have here this structure. wherein tatanggal na yung double bond natin. Nandito yung original hydrogen natin. Electrophile, it will add to the carbon with higher number of hydrogen. Then we have here our chlorine. Then the chlorine will attach itself to this carbon. Okay. So that is how our reaction will proceed. Okay. So for our last electrophilic addition, we have here our hydration. So by hydration, this is just the addition of water. So basically, when we talk of alkynes, hindi naman talaga sila na-hydrate. Hindi kasing bilis or kasing dali ng sa alkenes due to the lower reactivity of the triple bond towards electrophiles. So why? Because of the existence of or because of the electron cloud itself. So, hindi nagkakaroon ng, kumbaga, hindi ganong kabilis yung nagiging reaction. So, in that, we actually add sulfuric acid or our H2SO4 with the presence also of our sulfate. By mercuric sulfate that is HgSO4. So, hindi lang siya basta nangyayari yon. So, basically, when we talk about hydration, what happens here is we have the water. We need to add water. And it must be a catalyzed reaction wherein we have here our H2SO4 and our HgSO4. So, hindi magpo-proceed yung reaction when kapag hindi present tong dalawang to. So, what actually happens when it comes to hydration ay parang nagiging itsurang oxidation yung reaction natin. So if we have here our alkyne, we have there our triple bond, and we add water to it, in the presence of our H2SO4 and our HgSO4, nagkakaroon tayo actually ng tinatawag natin na keto-enol tautomerism. By tautomerism, our alkyne is first transformed into enol. By enol, we have there in, which is alkene, and ol, which is alcohol. To then it will be again transformed into a keto or our ketone. So, paano ba nangyayari yun? So, basically, we have here what we call our intermediate product, which is our enol, wherein we will have here an anti-addition of our water by our water, our H plus, and our hydroxide. So what will happen here is we will have here, there will be a breaking of one of the pi bonds, and we will have here our hydrogen and our hydroxide. So that will be our intermediate reaction, wherein it will actually also proceed to being a keto, wherein the last pi bond will actually be broken, and we will have here our hydrogen, and we will actually have a double bond about the our carbon here. So basically, that is, as you can see here, that will be H2O. Okay, so we added there our water. For example, let's take uh, let's take one propine or propine. So by propine, we have there our three carbon atoms. Then we have there our triple bond and our single bond. We have here our hydrogen, and we have here our CH3. Right. So if we added water here, and we have our sulfuric acid and our mercurous sulfate, what will happen here is first our we will have our enol, wherein our enol will look like this. So we have here our carbon, which is attached to our hydrogen. Since this carbon has more hydrogen atoms than this one, we will have here our hydrogen and our double bond. We have here our carbon. Then we have here an anti-addition of our OH or hydroxide. Then we have here our CH3. So this will be our enol, right? So by enol, we have here, since this is 3, 2, so we have here 1 prop propin propinil ba to? 1 propin 2 all. Bakit 2 all? Kasi yung OH natin ay naka-attach sa, alam ko propane to, wala na. So actually class ay hindi ba ako sure, pero balikan natin siya later on. Then we have here an enol. Then it will proceed to our keto-enol tautomerism, wherein actually class merong konting backward reaction towards the enol. So we will have here our C, and we will have here our 3 hydrogen atoms and single bond. We have here a double bonded oxygen to our carbon. Then we have here our CH3. So basically, we have here uh, pro- propanone. So yeah, we have there our propanone. Okay, so that is our hydration. So pasensya na kung medyo nagiging pa-complex yung ano natin. So again, this process is actually what we call our keto enol automerism. Okay, so moving forward, let's talk about reactions of acetylene, propyne, and terminal alkynes. So what is the similarities between these three groups? So basically, all of this are actually terminal alkynes. By terminal alkynes, the triple bond is actually bonded or located or positioned at the first carbon. So mapaanong acetylene man yan or aling propyne man yan, lahat sila ay nasa dulo or nasa first carbon yung ating triple bond. So when we talk about acetylene, propyne, and terminal alkynes, all of this actually we have here our sp hybridized carbon, lahat ng carbons nila, and or carbon about the functional group, such as they act as though it is electronegative. And due to that being electronegative, nagkakaroon actually tayo ng weak acidity or making acetylene, propyne, and terminal alkyne weakly acidic. So bakit ba siya nagiging weakly acidic? Due to the presence of our or due to the formation of or due to the presence of our hydrogen atom that is bonded to our hybridized carbon na pwede siyang i-release actually as proton. So ano ba yung sinasabi ko? By that actually class, we have here this basic or the general equation of our terminal alkynes. And our terminal alkynes can actually behave as acid, wherein we can form what we call here our anion and our H plus. And as you can remember, H plus actually is acidic or acid. And this one is actually called what acetylide anion. So due to the presence of or due to that behavior of terminal alkynes, nagkakaroon tayo ng weak acidity. And by that, pwede natin siyang actually i-compare sa acidity ng iba pang ano natin, ng iba pang known acids natin. So yung ilang known acids natin, by weak acids, one of the weak acids are actually water. Water actually has higher acidity than our acetylene, which is actually our acetylene has higher acidity than our ammonia. Ammonia being a basic compound and our RH or yung ating mga alkanes. So in that class, due to that, due to that existence of weak acid, we can actually expect that for acetylide ion as our conjugate base, we have here a strong base. So, alin yung strong base natin dyan? This will be our strong base. Okay? And that strong base, when we compare them to some known bases, acetylide ion is actually more basic than our OH or hydroxide ion. And it is less basic than our ammonium ion, which is actually less basic than our alkaline ions. Okay? So, dahil dyan, kapag yung ating mga terminal alkynes actually ay in-expose natin sa metals, yung halimbawa, yung acetylene, yung propyne, yung terminal alkynes natin, ay in-expose natin sa mga metals, nagkakaroon ng reactions. Not unlike or hindi katulad nung sa mga ano natin, sa mga internal alkynes natin. So dahil dyan, meron tayong actually ilang reactions na magkakarakterize or pwedeng mag-identify ng ating acetylene, propyne, and terminal alkynes. So this is that reaction. So if you have here your terminal alkyne, it can actually happen in three ways, wherein you can use what we call alcoholic, silver, aluminum, silver, silver nitrate, pwede ring exposure to sodium metal, again, another metal, and our sodamide, which is just a combination of ammonia and sodium. Magkakaroon actually tayo ng magkakaibang reaction. Wherein this reaction cannot actually happen with internal alkynes. So basically, what will happen here is for this one, we will have here our R. We will just replace our hydrogen since ito ay magiging negative. Ito ay magiging H plus or positive. That H plus will actually attach itself to the nitrate part. So what will happen here is we will have here our uh, acetylide ion and our silver. Actually, add na rin natin our HNO3. Okay? So basically, we will have here, kapag yung ating colorless na terminal alkyne natin ay in-expose natin sa alcoholic silver nitrate, we can actually have what we call this silver acetylide, wherein this silver acetylide will actually precipitate itself. Magkakaroon tayo ng silver na precipitate dun sa bottom ng glass natin. So wait, this is silver acetylide. Okay? And for the sodium, we will just have here what we call this reaction in having that R group in this triple bond and our acetylide. This acetylide will actually form an ionic bond with our sodium metal, therefore producing hydrogen gas, which will actually appear as bubbles. Okay? So, and lastly, for the sodomide reaction, if we have here this R group, and we have here this acetylide, again, same reaction, we will have here our salt, or our ionic compound, then we will be releasing our ammonia, making this one have a basic condition. So kapag chinek natin yung yung substrate natin gamit ang litmus paper, magkakaroon actually tayo ng tinatawag nating basic na compound na structure or basic na condition. So basically, if you provide any terminal alkynes or expose any terminal alkynes to these conditions wherein you will add alcoholic sodium nitrate or your sodium metal or your sodamide, you will have these reactions wherein magkakaroon ka ng precipitate, pwede kang magkaroon ng bubbling due to sodium metal, and lastly, you can also have a basic condition using our sodamide, which will not happen with uh, internal alkynes. So basically, if you have 2-butene and you expose it to alcoholic silver nitrate, nothing will happen. Same with sodium, same with sodamide. So these reactions, utilizing the acidity and the basicity, the acidity of acetylene, propyne, and terminal alkanes will actually help you determine whether your alkyne is a terminal alkyne or an internal alkyne. Okay? So in the habit or in the thought of having analysis of alkynes, we actually have different or some other analysis of alkynes wherein we can test different aspect of being an alkyne. And one of the analysis that we can perform in alkynes is actually the test for unsaturation. So as you may have remembered, on our alkenes, we actually have reactions or we have reaction mechanisms wherein we can check for the unsaturation. By unsaturation, it is the presence of a double bond or a triple bond of an organic compound. So in that case, for the test of unsaturation, we can actually use this simple chemical test for alkenes, wherein we have here our Br2 in carbon tetrafluoride. We can also use our oxidation reaction, our cold dilute potassium permanganate. Same same test for the unsaturation. So basically kapag hindi saturation or pag saturated sa hydrogen yung ating organic compound, hindi magkakaroon ng reactions or hindi magkakaroon ng magiging negative na reaction natin. So for the bromine and the carbon tetrafluoride, magkakaroon tayo actually, we will have a discoloration of red-orange color of bromine. Mawawala yung kulay ng bromine natin. And for the cold dilute KMNO4, we will have formation of brown precipitate and disappearance of purple color of the KMNO4. So, same concept when it comes to the KMNO4 and BR2 bromine and tetachloride. So, yung ano natin, it will also for bromine, ayun, addition of halogens lang ulit yan. And for the cold dilute KMNO4, it will proceed to hydroxylation. So by hydroxylation, we will have hydroxyls about the triple bond. So if we have more hydroxyl, magkakaroon actually tayo ng uh, quad or tetra na hydroxyls. Okay? So for the next step is the test for terminal alkynes. We actually have discussed this, so we can for the most visible or for the most yung pinakamadali na pagte-test ng terminal alkynes is using our alcoholic alcoholic silver nitrate. We can use that, but we can also use sodium metal, although sodium metal is not so stable. By not so stable, it cannot be exposed to water. So, medyo, ano siya, hindi ganun kagandang gamitin at hindi mo ganun kadali i-procure. Same with sodamide. Mahirap ding i-test minsan kasi yung basicity. By mahirap, hindi mo lagi siyang matetest. So, unless lagi kang merong pH meter or meron ka laging litmus paper. Not unlike alcoholic silver nitrate, you just need to look for precipitate, which will look like silver. Okay, and the last test will be our ozonolysis for internal and terminal alkynes. So for the checking of ozonolysis or for the checking whether your alkyne is internal or terminal, you can actually use ozonolysis. So why is that? So basically, if you have internal alkyne, say we have here our R, then our carbon triple bond, and another R. This is internal because R group is our alkyl group, and we proceed with ozonolysis. So that is you first add your ozone, then you expose that to zinc and your acid. So what will happen here is we will actually have by ozonolysis, as you may have remembered, you need to cut the the bonds here. So by cutting the bonds here, we will actually have here this is R1, this is R2. We'll have here our R1, which will actually produce one carboxylic acid, and our R2 will also have our carboxylic acid. So if we have our terminal alkyne, so we have there our R group, our carbon-carbon triple bond in our hydrogen, so that is terminal, and we expose that to ozone and our zinc in acid. What will happen here is we will have our R group, our our carboxylic acid, and our this one will be and we will have here our carbon dioxide. Okay, so that will be the difference of those two. Both of them will proceed to have what we call acids or carboxylic acids. So both of them will be acidic. But when it comes to terminal alkynes, you will notice that we will have here our carbon dioxide, which is actually a gas. And by gas, if you see evolution of gas during your ozonolysis, it just means that you have your terminal alkyne. So, for internal, there will be no evolution of gas. Walang lalabas na gas dun sa iyong ozonolysis. But, para dun sa terminal alkyne, magkakaroon ka ng evolution of gas. Okay? So, hopefully, nakuha nyo yung mga reactions natin. So, that will be the last reaction for our alkynes. So, basically, for today, we talked about the general structure of alkynes. We also talk about naming our alkynes. We also talk about our the physical properties of alkynes. And lastly, uh, we also discussed the reactions of alkynes, which actually follows the reaction of alkenes, wherein we have there our hydrogenation, uh, our electrophilic addition, wherein we have the addition of halogens, addition of hydrogen halides, our hydrolysis. Also, we also discussed the reactions for terminal alkynes. By terminal alkynes, we mean ethyne, propyne, and other terminal alkynes. And we also talked about the analysis of alkynes. So in that, we end this video here. Thank you and have a nice day. Bye.